Welcome to Brain Vision.
So welcome to a new problem. This time we have two free spirited. So this is what we're gonna have before. So this is what we're given. So we have two free spirited uh, otters. Okay, we have two free spirited otters, and they are moving towards each other. We have the first one, A, has a mass that happens to be 5.75 kilograms, and the other is moving towards the right with a initial velocity of 6 meters per second. And then the second order is uh, moving, has a mass of 7.50 kilograms and is moving towards the left with an initial velocity of negative, because the left is negative and then the right is positive. So if you're moving towards the right, that's positive. If you're moving towards the left, that's negative. So the second order has a velocity that happens to be um, uh, 5 negative 5.00 meters per second. And then what's going to happen is afterwards they'll collide with each other. The two free spirited otters will collide with each other. And so there's going to be a final common velocity for them. The final common velocity for them. So we want to find out the magnitude and direction. Okay, we want the magnitude and direction of this final velocity, okay, for these two organisms, and that's magnitude and direction. Uh, that's what happens after. And then the second thing, that's in part A. In part B, the second thing we want to find out is um, the mechanical energy lost in the process, or what they call dissipated in the process. Um, in this case, we have a frictionless surface, so we'll use the law of conservation of energy to show that the initial momentum equals to the final momentum. That will help us isolate the final velocity. So the initial momentum equals to the final momentum. We can switch that, and when they collide with each other, then they end up having a common velocity as part of the final momentum. The initial momentum of the order A is VAI, and then the final momentum of the second order is MB VBI. Okay, VBI. I think we do have to change this to BI just to make sure we have the same naming convention that's consistent. And so the final for this one, the final velocity happens to be MA. VA, that's the initial momentum of the first order, and then the initial momentum of the second order divided by the mass of the first order, and then the mass of the second one. This will be a minus, so we have 5.75 kilograms times positive 6 meters per second, minus, because this is a minus, mass of the second one, 7.50 kilograms, times that 5 meters per second. We already dealt with the minus, and you want to divide all of that by the sum of the two masses of the two orders. So 5.75 kilograms plus 7.50 kilograms. And that gives us a final solution of negative. So this is your final velocity becomes equivalent to negative 2 point on, or rather negative 0.0000, not 2, 0.2264 meters per second. In terms of the requirements of the problem, we're simply going to say that the magnitude is just the speed, which happens to be 0.2264 meters per second, and then the direction is towards the left. Okay, so it seems that the heavier one will push the lighter one towards the left. Second part of the problem requires us to determine the changes in mechanical energy, or the mechanical energy loss, which is equivalent to the initial kinetic energy of the system. Okay, initial kinetic energy minus the final kinetic energy. The initial kinetic energy is the kinetic energy of um, the first order, which is MAVA initial squared, plus the second order, which is MBVB initial squared. And then we want to subtract the uh, the final kinetic energy, which is the common kinetic energy. So 1/2 MA plus MB V final squared. Okay, V final squared. When you plug in the numbers for this problem, you get um, 1/2 MA is mass of A. If you go back, you see mass of A is 5.75 kilograms. And then the initial velocity of A happens to be 6 meters per second. We want to square that. Plus 1/2 mass of B happens to be 7.50 meters per second. Okay, 7.50, not meters per second, but kilograms. And then times the velocity of B, which is negative 5 meters per second, the initial velocity, which is negative 5.00 meters per second. The sign of the velocity doesn't make a difference because you're going to square it anyways. And then 1/2 mass of A is 5.75 kilograms plus mass of B is 7.50 kilograms. And then you want to put in the final velocity right there before you square it. We got the final velocity as 0.2264. It's negative 0.2264 meters per second, and that's going to be squared. So if you plug in the numbers for that, if you plug in the numbers, 7.5 negative 5 squared plus that, the energy, remember, energy dissipated is going to be in terms of joules. And so you plug in the numbers for this one, you get 197.25 joules, and you subtract the common energy between the two of them, which is round about 0.3395 joules, and therefore the energy lost or dissipated in the process, the mechanical energy becomes 196.91 joules. Hope you enjoyed the problem. Feel free to ask any questions. Have a wonderful day, and looking forward to the next problem. Okay, thanks. Bye.